People often ask, could there be other worlds hidden beside our own? Maybe a universe where history turned out differently, or where the laws of nature are not the same. Now, we will explore this question together. Parallel universes, are they real or only imagination? For centuries, humanity has asked the same haunting question. Are we alone? Alone in the vast cosmos, alone in history, alone in existence. But modern science takes this question further, to a place both fascinating and unsettling. What if we are not even alone in our own universe? What if reality itself is only one branch among countless others, parallel universes, hidden beside ours, unreachable yet real, science or fiction? The idea of parallel universes sounds like fantasy, a theme for novels and films. Worlds where history turned on a single decision. A universe where you chose a different path. Another where dinosaurs never went extinct. Perhaps even a cosmos where physics itself obeys laws so strange that we could hardly imagine them. And yet, behind the stories and the myths, serious science grapples with this very possibility. The roots of the multiverse begin with quantum mechanics. In the early 20th century, physicists discovered that the smallest building blocks of reality do not behave like ordinary objects. Instead, they exist as waves of probability. An electron does not have one fixed path. It lives in many possibilities until the moment we measure it. To us, the result looks definite. But what happens to the other possibilities? Do they vanish? Or do they play out in hidden worlds of their own? This question inspired the many worlds interpretation. According to this bold idea, reality splits each time a quantum event takes place. If a particle can go left or right, then in one universe it goes left, and in another it goes right. Both universes are equally real, branching endlessly from every interaction. Imagine this applied to everyday life. You choose to open a door or leave it closed. In one universe, you entered the room. In another, you never did. In a third, you walked away entirely. Every possibility, no matter how small, creates its own universe. This means there could be infinite versions of you, each living out a slightly different life. In one, you succeeded in your greatest dream. In another, you failed completely. Somewhere, you are rich. Somewhere, you are poor. Somewhere, you never even existed. The many worlds interpretation takes the strangeness of quantum physics and extends it to the very structure of reality. But quantum physics is only the first door. Cosmology, the science of the universe itself, provides another. The Big Bang, our best model of the universe's origin, may not have been unique. Many physicists believe in cosmic inflation, a moment when space expanded faster than light itself. Inflation explains why the cosmos looks uniform on large scales. But inflation also suggests something else, that the Big Bang may not have happened only once. Space may be a vast foam of bubbles, each bubble its own universe. In this vision, our observable universe is just one bubble. Beyond the horizon, beyond what we can ever see, lie countless other bubbles, each expanding, each with its own galaxies, stars, and maybe even life. Some may collapse in an instant. Some may last trillions of years. Some may follow laws of physics entirely alien to us. And in a few rare ones, conditions resemble ours closely enough to allow beings who ask the same questions. String theory, another ambitious framework, adds yet another layer. To make sense of the universe, string theory requires extra dimensions beyond the three of space and one of time. These dimensions may curl up invisibly or stretch into vast hidden spaces, and within them, entire universes could exist, separated from ours, like pages in a book. Different solutions of string theory lead to different physical constants, meaning that across the multiverse, reality itself could take countless forms. In one universe, atoms form as we know them. In another, Chemistry as we understand it is impossible. In yet another, there is no light at all. The evidence for parallel universes remains elusive. We cannot travel to them. We cannot communicate with them. But physicists still search for indirect signs. Some suggest that irregularities in the cosmic microwave background, the faint afterglow of the Big Bang, might hint at collisions between our universe and others. Others look to mathematics, arguing that if our best theories demand a multiverse, then perhaps it exists. Whether or not we can observe it directly, but not everyone agrees. Critics point out that a scientific idea must be testable. If parallel universes are forever hidden, then can we truly call them science? Or are they metaphysics, ideas that inspire but cannot be proven? Without evidence, the multiverse could remain nothing more than a story, a grand speculation. And yet, history reminds us to be cautious. Many ideas once dismissed as fantasy later turned out to be real. Black holes were once thought absurd, a mathematical curiosity that could not exist. Today, we photograph their shadows. Time dilation, the slowing of time at high speeds or in strong gravity, was once unimaginable. Now it is measured every day with satellites. Quantum entanglement, the strange link between particles, was once called spooky action at a distance. Today, it forms the basis for quantum communication. Could parallel universes one day join this list? The question is not only scientific but also philosophical. If infinite universes exist, then every possible history is real. Every decision you might have made, every chance you missed, every life that could have been, they all play out somewhere. Does that make our choices meaningless or more profound? If every outcome exists, what does it mean to live in this one? Here, now. Some scientists use the multiverse to explain why our universe seems so finely tuned for life. The laws of physics here appear balanced in ways that allow stars, planets, and chemistry. If any constant were slightly different, life might be impossible. Why do we live in such a lucky universe? The multiverse provides one answer. If there are countless universes, each with different laws, then it is not surprising that at least one of them supports life. We exist in that one, because only here could we ask the question. But even this reasoning is controversial. Some call it the anthropic principle. We observe the universe to be life-friendly because otherwise we would not be here. Others argue it is a weak explanation, one that avoids deeper truths. Perhaps there is still a hidden law, a principle that makes our universe the way it is. Perhaps parallel universes are not needed at all, and so the mystery endures. Are parallel universes science or fiction? For now, they are both. They exist in the equations of physics, in the possibilities of cosmology, and in the imagination of humanity. They inspire stories, fuel debates, and push the limits of what science can ask. Picture this. Somewhere, another version of you is hearing these words. In another universe, you never found this video. In another, you are not even human. And in yet another, there is no you at all. Only silence. Whether the multiverse is real or not, it teaches us something vital. The universe is stranger, deeper, and more complex than we can ever fully imagine. And even if this universe is the only one, it is already vast beyond comprehension. A single cosmos of galaxies, stars, and mysteries, stretching farther than we can see. To explore it is already to explore infinity. So, are parallel universes science or fiction? The answer has not yet been written. But the search itself, the act of daring to ask, may be the most important part of all. Because every time we imagine new worlds, we expand the limits of our own. And in that sense, the multiverse already exists, not only in equations, but in the human mind.